Hi, I'm Zeke Peach with Elektro-Automatik, the leader in programmable DC power supplies, electronic loads, and bidirectional power supplies. Today I'm going to talk to you about setting the current limit on your voltage source. So all of our EA power supplies are voltage sources, meaning that they regulate voltage. The current coming out of them is dependent on the load. So if you think of your load as a resistor, your current will be calculated based on the voltage coming out of the power supply and the value of the resistor. So think of any other load the same way, regardless of what circuits you have set up. So to demonstrate that, we've got a PSI 9040-60 as our power supply and an EL 9080 DT as our desktop electronic load. So as we come down here, we see our PSI right now is set to 12 volts. We've got a current limit of 14 amps, meaning I believe that this load, either based on my real calculations or my predictions, is not going to draw more than 14 amps. And in fact, 14 amps is just under the value where we might, that might be too much for our circuit. So it's really meant to protect the circuit, not meant to determine how much current is going into your load. So if I turn on the power supply, we've got now 12 volts. We're in constant voltage mode. No current coming out because our load is not on, and of course no power. So if I go over to our load is set to 0 volts but 9 amps, and I'm going to go ahead and turn the input on. And right away our load goes into CC mode, constant current. Just like what we talked about, our load is controlling the current, or how much power is being drawn from the power supply. And the power supply is the one dictating the voltage. So on the other side here, back with the power supply, what you'll see, the reason why we want to set our current limit a little higher than what we think is going to, the circuit's going to draw, is if I start to lower this current limit down to 9 amps, what you'll see is the voltage. Right now we're basically at a perfect spot. We're right at full power for our power supplies. But again, if we increment just slightly above 9 amps, excuse me, I have to go over to our load, and if I increment the load up just a little bit, here we go, then immediately you see your voltage fold back or drop down. And the reason for that is the power supply does not want to exceed your 9 amp current limit over here. So in order to do that, the power supply determined that it needed to fold the voltage back. If this was a resistor, the voltage wouldn't necessarily need to drop because the current would be constant. But it still would drop back slightly. In this case, we have an electronic load that only requires a few hundred millivolts to conduct. So that's all the voltage it requires in order to draw 9 amps. So it's a little bit different than if you had a resistor or a true circuit on the hooked up to the output of the power supply. But again, that's why you want to primarily stay in constant voltage mode. You can see if I raise my current limit up on the power supply, now I'm not hitting the current limit anymore and I'm getting the full voltage out. So those are just a couple things you can do. And again, just something to keep in mind when you're setting the power supply up for the first time. The biggest thing is, what do I set my current limit to? Well, set it a little bit above what you think you're going to need, and then you can always increase it a little bit after you get started. Thanks, and if you have any questions, please visit us at the link below. If you have any ideas for videos, demonstrations, things you'd like to see, please leave those in the comments and we'd be more than happy to do that for you. Thanks.